Last time we created an ASP.NET REST API that authenticates Firebase users and returns data for the authenticated Firebase user. So this time, I want to hit this API from our WPF application so that we can get data back for the authenticated Firebase user in our app. So just to review our API, we now have this /get endpoint, and if the user is authenticated via Firebase, then we return this secret message response. So this is the endpoint that we want to hit from our WPF application. So ultimately what I want to do with this secret message is display it on the home view of our application. So this is the page that the user navigates to after logging in. So let's start from the UI layer and work our way up to eventually getting this data from the API. So on the home view, we have this first row, and this has the hello username content that we added a while back. So underneath this, we're going to have another row, and this second row that we have is going to take up all the remaining space of our UI, and our hello username row is going to take up auto height, so just as much space as it needs. So it shouldn't take up too much space, should just be really like a header, which is what we intended. So underneath that, we're going to have our secret message, which is just going to be a text block. Going to go in grid row 1. We're going to align it in the center vertically and horizontally. We should do text align center as well, in case our text wraps to multiple lines. And then we should make this text pretty big too. Maybe we'll do 48 to start with. We'll experiment. And then lastly, we're going to bind to a secret message property that will add to our home view model that'll provide the text block with the text data. So the text for this text block is going to be a binding to the secret message, which is going to be on our view model. So before we get into debugging this, let's move up to the home view model and let's add a property for the secret message. We're going to make this a prop change because down the road we are going to have to set this with whatever data comes back from our API, but it's going to be a string. We'll call it secret message. Let's rename that. And now in the constructor, we'll just set secret message to hello world. So let's see how this looks. Let's set our WPF app as the startup project. And let me log in real quick. So here we go. So login was successful and we get hello world on our UI. I guess one thing we should worry about is margin. So I think if we made this window really small, it'd get pretty close to this content over here, but just to be safe, we should have just a little bit of margin on here, maybe like 20. And I'm just now realizing we need a scroll viewer around our entire app, I believe. So if we come over to the main window, we should surround our app in a scroll viewer. And there we go. Now if the window gets really short, we can just scroll. And then also need to set vertical scroll bar visibility to auto, because as we can see, it's visible even though we don't need it. So let's set that vertical scroll bar visibility auto. And there we go. Now it is gone because we don't need it. All right, so pretty satisfied with the UI, even though it's pretty simple. But now let's get into populating this secret message. So when we instantiate this home view model, we're going to want to kick off an async command that's going to hit our API and update this secret message property. So let's create a command that'll do that. Let's add a new item in our commands folder. We'll call this the load secret message command. We'll inherit from async command base from our MVVM essentials. So let's implement that. We're going to need our home view model in here since we're going to have to update that secret message property. So let's get the home view model as a field in our command and get that through the constructor. Let's make this method async. And for now, let's just take our home view model and set the secret message to hello world. So of course, we're going to have to come back to this and actually hit our API. But let's get this command wired up to our view model. So back to the view model, no longer setting the secret message here. Instead, we're going to have an I command for our load secret message command. That's just what we'll call this. Let's import I command. And let's initialize that command down here. So set the load secret message command to the command that we just created. So a load secret message command. Let's import that. And that's going to have to take in this home view model instance. So now we just need to execute this command. So we might be tempted to just take the command and just execute it right here. But in my opinion, constructors really shouldn't be executing complex logic. So instead, we're going to have a static factory method on here. And what this method is going to do is it's going to instantiate a home view model instance. It's going to execute this load secret message command and then return the instantiated home view model. So that being said, that's going to be a static method that returns a home view model. We'll call it load view model, and it's going to need this authentication store passed in because it's going to have to initialize the home view model. So first off, let's do that initialization, passing in the authentication store. Next up, we're going to take the home view model and take the load secret message command and execute it with just nothing as the parameter, and then we'll return the initialized home view model. So now we need to call load view model instead of calling the constructor when we instantiate this. So up in our app.xaml.cs, instead of instantiating the home view model, we're going to call load view model. So now we'll return a home view model that's begun loading the secret message. So now if we run this, we should still see the secret message on the UI, except we're going through this load secret message command. So let's put a breakpoint there to verify that this command gets executed. So let me log in. Here we go. We execute the command and we update the UI as we see here. So now the next step, instead of hard coding the secret message here, we're going to have to get it from our API. So we could just create some kind of service class that spins up an HTTP client and makes a GET request to our API. But instead, what I want to do is leverage Refit to execute the HTTP request against our API. So the nice thing about Refit, it does use an HTTP client under the hood, but we don't really have to deal with it or manually call the HTTP client. All we have to do is define an interface that Refit will use to execute the HTTP request that we specify. So we want to create an interface that will tell Refit how to execute this GET request on our API. And if you're unfamiliar with Refit, I've covered it more in depth in other places on my channel, but of course, we'll walk through it here as well. So in our WPF app, I'm going to add a new folder for queries. And then in our queries folder, let's add an interface. And this will be the interface that describes to Refit how to hit our API. So we'll call this the get secret message query. This will return a task because we're hitting our API asynchronously, and we'll get to the result of this task in a second, but ultimately we just want to execute this query and we won't be passing in any parameters. And then since Refit's going to be using this interface, we're going to have to describe to Refit how to execute the HTTP request represented here. So this is going to be a GET request. Let's import that from Refit. And I forgot we need to install Refit. So let's go to manage NuGet packages, of course, and let's search for Refit. And we're going to install Refit, first option here. And then we also want to install refit.http client factory. And this provides extension methods so that we can register our Refit clients with dependency injection. So definitely want this. This will simplify a lot of things for our setup. And we should be good to go here. So now back to our query. Let's import get from Refit, and the path for this GET request on our API is just going to be /. So that's what we have specified on our API, just a GET request to /. So now looking at this API and getting back to the result for this task, as we can see on the API, we serialize this secret message response object. So on our Refit interface, this is the object that we want to tell Refit to deserialize the response into. So right here, I would want the secret message response as the result here. So instead of redefining this response object in our WPF application, we can just move this into a shared project that our API and our WPF app can reference, and that'll ensure that our response types are in sync. So let's add a new project to our solution. This is going to be a class library. So let's create that. We'll call this secret message.core, and we'll stay on .NET 6 like everything else. So create that, delete this class 1 that we don't need, and we can just move this responses folder from our API over to secret message.core, and then delete it from secret message.api. And then in secret message.core, let's change the namespace to be secret message.core secret.responses. And now back in our API, we're going to have to reference this type. So let's add a project reference from our API project to our core project. And while we're here, let's also do that for the WPF project as well. A project reference to secret message.core. So all good on project references here. And now in our API, we can reference the secret message response from our core project. And let's get rid of the old import. So it should be good on our API project. Everything should still work as expected. And now in our WPF project, we can reference the secret message response. So reusing that class between our API and our client. So now we should have what we need to register this interface with Refit. So open our app.xaml.cs. We're going to take our service collection and add a Refit client. Let's import that from Refit. And this is going to be for that get secret message query interface that we just created. But as we see on this interface, all we're doing is telling Refit to hit this /endpoint. But the issue is that Refit doesn't know the base URL of our API. All that we've told Refit is the path on our API. So if we run the API real quick, let's set this as the startup project and run it. As we see, Refit doesn't know that it's going to have to hit HTTPS localhost port 7297. So let's tell Refit that this is the base URL of our API. So let's copy that. And now extending this add Refit client method, we can call configure HTTP client. So what this does, of course, is configure the underlying HTTP client that Refit is using for this interface. And we can configure this with a callback. So we can set the base address to a new URI, and this will point to our API. So we could just paste our base URI here, but I actually want to move this into app configuration because this URI is likely going to differ for development versus production. So on development, we're going to hit localhost, but in prod, we'd hit wherever our API is running in prod. So let's put that just in our app settings.json for now. And the key we'll give it is secret message API base URL. And let's paste that in here. So now let's take that key and reference that in our app.xaml.cs. So instead of pasting the URL here, let's get it from our configuration. So we'll get value. We want to get back a string and just paste in the key that we specified in our app settings.json. So it should be good now to hit our API. So let's use this interface in our load secret message command. So we'll add another field for the get secret message query. Let's import that and we'll get this passed through the constructor. Let's add a parameter for that. And now let's take that query and execute it. This is async, so let's await it. And let's get back that secret message response. Let's import that response object. And let's use that response to set the secret message on our view model. So let's just take the message from that response and set it on our view model. Now, of course, this query is making an HTTP request, so it could fail. So let's wrap this in a try catch as well and just move all of this in here. And if it fails, we'll just throw up a message box for now. Let me just copy one of these message boxes from another command. So we'll take this login failure one and move it over here. Let's import message box. And instead of login failed, we'll just say unable to load secret message. And then again, since we're making an HTTP request, there's a chance that the request could take a while. So it probably would have made sense to add loading indicators to our UI, but maybe we'll come back to that in the future. And then lastly, before we can run this, we're gonna have to pass in this secret message query to this command. So in our home view model, we're gonna have to pass in the query to this constructor for the home view model. So let's import the get secret message query, which we'll pass in to our command now. And now also we'll have to add this parameter to our load view model method and then pass in the get secret message query to our constructor. And then finally funneling up to the app.xaml.cs, we're gonna have to resolve our get secret message query from dependency injection. So let's resolve that, the get secret message query, and we should be good to go. And then before we run this, I do want to put some breakpoints down. So let's put one at the beginning of our command. And in the odd case that our query throws an exception, we'll take a look at that exception and put a breakpoint here as well. And finally, for debugging, we're going to need our API running in the background. So we can set both our API and our WPF app as the startup applications. So on our solution, let's set startup projects, and let's set multiple startup projects. And for our API, we can just start this without debugging. And for our WPF app, we can just start it with debugging. So let's apply this, and we should be good to go. So let's start this, and our API is running. That's good. Let's log in. So here we go. Moving on to the home page, we're executing our load command, and let's continue. And ooh, we hit our exception. So let's look what could have gone wrong. And of course, we're unauthorized because we didn't send our Firebase access token for the logged in user to our API. So that is going to be the final piece of the puzzle. And we can configure all this when we register our Refit client. So in this add Refit client chain, we can chain on another method, and we want to add HTTP message handler. And we'll have to specify the type of our handler. So we're going to create some kind of Firebase auth HTTP message handler. And what this handler is going to do is automatically append our Firebase access token to our HTTP request. So let's add another folder in our project. We can call this HTTP, and we're going to create our Firebase auth HTTP message handler as a class in here. So let's create that, a class for our Firebase auth HTTP message handler. And then we'll inherit from delegating handler. And this delegating handler takes on a lot of the boilerplate for HTTP message handlers. So now all we have to do here is override send async. And now we can do anything with the HTTP request before we actually send it. So what we want to do is set the authorization header of our request to be our authenticated user's Firebase access token. So as we recall, when we got to the login logic, we've set that Firebase access token on the authentication store, because on here we have this Firebase auth link, and this Firebase auth link has the Firebase token on it. But this Firebase token could be expired because access tokens have expiration times. So this Firebase auth link also has a method called getFreshAuthAsync, and what this will do is return the current Firebase token if it's not expired. But if the access token is expired, it'll automatically refresh it and return it from this method. So this will be nice so that we can implement automatic token refreshes, and users won't have to keep constantly logging in whenever their token expires. But anyways, we're gonna have to get this Firebase auth link into our HTTP message handler. So for simplicity, what we're gonna do is just inject the authentication store into this HTTP message handler, and then we can add a method to that store to get the Firebase auth link that we need to make the request. So let's get the authentication store as a field in here and get that passed through the constructor. So we'll register this handler with dependency injection. And now we're going to use that authentication store to get back a Firebase auth link, which is going to have our Firebase access token on it. So we're going to import Firebase auth and get this Firebase auth link, and we'll get that from the authentication store. And on this authentication store, we're going to have a method. I guess we'll just call it getFreshAuthAsync. So the same name that the Firebase auth link has, we'll just keep that for consistency. But let's generate that, and we'll implement that in a second. But regardless, we're going to get back this Firebase auth link, and using that, we can set the authorization header on our request. So let's instantiate an authentication header value here. Our authentication scheme is bearer token authentication. So let's set bearer, and now we just have to pass in our Firebase access token. So let's grab that from the Firebase auth link and set it. And now we should be good to go with this HTTP message handler. So all we do is get a fresh Firebase auth link. If our Firebase auth link was expired, we'll get a refreshed one, so automatically taken care of token refreshes here, and then we'll just set our authorization header so that our API can authenticate us. So now moving into the authentication store, we're going to have to implement this method. And for this, we can just pass through to our current Firebase auth link that we got back after logging in. So we'll call getFreshAuth async and get back the response of that. And actually, we don't even have to make this method async. We can just pass through to our auth link. So lastly, let's register this HTTP message handler in our app.xamarin.cs. So let's import that. And we're also going to have to register that with dependency injection. So let's take our service collection, and we want to add this as, we can register it as a transient. So we get a new one back for every time we resolve it, which shouldn't be an issue because we don't really store any state in here anyways. But there we go. We should be good to go. So I'm going to litter some breakpoints everywhere, and then we'll get into debugging this. All right, should be ready to test this out. If we look at our API, the secret message that we should get back and we should display in our UI is Firebase is cool. So let's run this and let's log in. So submit. And here we go. First step is we execute this login on our authentication store, passing in our username and password. Let's continue from here. So executing login on the authentication store. This hits Firebase auth and signs us in. And with that, we get back this Firebase auth link that we store on the authentication store. We'll use this later, but should be good here. Let's continue. So here we go, successfully logged in. Okay, and that takes us to the home view. So now we're loading our home view model. And when we load this, we execute this load secret message command. So we're going to execute that. Here we go, executing. Let's execute our get secret message query. So this is where we actually make the HTTP request to our API. So let's continue here. And now we added this HTTP message handler. So before we actually execute the request, we want to set this authorization header on the request so that our API can authenticate us. So to do that, we use our authentication store to get our Firebase token back. So let's continue here. And at this point, we're inside of our authentication store and using our Firebase auth link to get a fresh access token in case our current one expired. So this current Firebase auth link, this is what we got back when we logged in. So using it here to get a Firebase token as well. And we can do that since we're authenticated from this login part. But now continuing again. So I should have put a breakpoint here. But here we go. We can see here that this query was successful. We got data back from the secret message query. And at this point, we're setting that on the home view model. And whoop, I see it does say what we wanted. Firebase is cool. So we have successfully made a request to our API, and we got data back for the authenticated Firebase user. So I feel like that debugging session was a good summary of everything that we accomplished in this part. So hopefully you can apply these concepts to your own application to get data for authenticated Firebase users against backends or APIs that use Firebase authentication. Aside from that, if you have any questions, criticisms, or concerns, be sure to leave those below in the comment section. If you enjoy the video or are enjoying the channel, consider becoming a member. Other than that, leave a like or subscribe for more. Thank you.